Hey everyone, and welcome. We're about to dive into something really cool today. We're talking about one of the biggest shakeups in AI history, how a trick for understanding language completely flipped the script on how computers see the world.
So let's just start with this one. Kind of wild idea. What if an AI could look at a picture and read it like a sentence? Not just see pixels, but see a sequence of meaningful parts. Like reading it word by word. Hold on to that thought, because that single question, it's the key to everything we're talking about today, vision transformers.
But, before we can get to the new hotness, we got to talk about the old champ, the king of the hill for years in computer vision, the convolutional neural network, or CNN. For a long, long time, these things were the absolute best, but they had a huge, fundamental blind spot.
All right, so how does a CNN actually see? Well, picture this. It's got these little things called filters, and you can just imagine them as tiny magnifying glasses. It slides them all over an image, piece by piece. And each little magnifying glass is only looking for one super specific thing, maybe an edge or a curve or a certain splotch of color. It's a very, very local, piece by piece way of looking at things. And right there, that's the big trade-off. CNNs are amazing at spotting those little local patterns. But, and this is a big but, because they're always looking through that tiny magnifying glass, they totally miss the bigger picture. They just can't grasp how something happening in the top left corner might have anything to do with what's going on in the bottom right. This whole thing boils down to a core assumption that's like hardwired into every single CNN. It's a fancy term called translation invariance, but all it really means is this. If a filter finds what it's looking for, let's say the shape of a car, it doesn't care where it found it. A car is a par, and it's just as valid on a road as it is, well, somewhere it shouldn't be. And this is exactly where that whole idea just completely falls apart, right? A filter sees a car on a road. Great, no problem. But that same exact filter will spot a car on top of a skyscraper and shout, "Hey, I found a car," with the exact same level of confidence. It has zero global context. It just doesn't get that one of these things is totally wrong. So you've got these three core ideas: locality, translation invariance, and something called weight sharing. Together, these are what we call inductive biases. The best way to think about them is as built-in assumptions or shortcuts the AI takes. And look, they make CNNs super efficient, for sure, but they also trap them, locking them into this very narrow, context-blind way of seeing everything. Okay, so here's the twist. The solution to this huge problem in computer vision, it didn't come from the vision world at all. Nope, it came from a completely different field, natural language processing. It came from AIs that were built to understand words. So let's just put this on a timeline for a sec. Back in 2012, this thing called ResNet comes along and just dominates, proving how incredible CNNs are. And that kicks off like a decade of them ruling the world. But then, in 2017, this paper with an amazing title, "Attention is All You Need," drops. It introduces the transformer, and for language AI, it literally changed the entire game. So what's the secret sauce here? It's this incredible mechanism called self-attention. And what it does is, instead of looking at words one by one, it lets the AI look at every single word in a sentence all at once. And it figures out how each word relates to every other word, no matter how far apart they are. It's all about context.
So in a really simple sentence like all dogs are animals, self-attention is what helps the AI connect dogs to animals. Super important link, right? But it doesn't just work on simple stuff. It can do this for crazy, complex sentences, building this huge web of relationships to figure out what's really being said. This is where modern AI gets its deep, deep understanding of context. And this is what led to the big aha moment. You had these researchers at Google who basically asked a crazy question. Wait a minute, what if we just stopped treating images like a grid of pixels? What if we treated them like a sequence of information, like a sentence? It was a totally wild, out there idea at the time. And the title of their paper from 2020 just says it all. An image is worth 16 by 16 words. How great is that? It's not just a clever name, it's literally the entire recipe for a brand new way for computers to see.
Okay, so here is the central analogy. It's super simple. A regular transformer, for language, takes a sentence and breaks it into words. We call them tokens. So a vision transformer, or a VIT, does the exact same thing to an image. It chops the picture up into a grid of little squares, or patches, and each one of those patches becomes a token. All right, so how does this actually work? How does a VIT take a bunch of little squares and figure out what the whole picture is about? Let's walk through it.
The whole process is actually pretty elegant. Step 1, you chop up the image into those patches. Easy enough. Step 2, you take each patch and you flatten it into a long string of numbers. That's a vector, which is just a format the AI can understand. Then, step 3, and this is super important, you add positional info. This tells the AI, hey, this patch came from the top left, this one from the bottom right. Then you add this special little classification token right at the start of the line. We'll get back to why that's so cool in a sec. And finally, the whole sequence of patches gets fed into the transformer, and this is where the magic happens. The self-attention kicks in, and it looks at how every single patch relates to every other patch across the entire image. It's building that global picture that CNNs could only dream of.
Okay, so remember that special classification token, the CLS token? Here's the truly brilliant part. As the transformer is figuring out all the relationships between all the image patches, that little CLS token is just sitting there at the front, acting like a sponge. It soaks up all the most important information, all the context from the entire image. So by the end, all the AI has to do is look at that one token. That one token holds the summary of the whole picture, and that's how it makes its final decision. So this jump from just scanning locally to understanding globally, it's a completely new paradigm, a whole new way for AI to see our world. But as you might guess, all this new power comes with a pretty big catch. See, because VITs don't have those handy shortcuts that CNNs have, that built-in assumption about locality, they are starting completely from scratch. They have to learn everything. And to do that, you need an absolutely mind-boggling amount of data. We're talking about pre-training them on datasets with hundreds of millions of images, just so they can learn the absolute basics of what our visual world even looks like. Okay, so let's just wrap this up with a quick side-by-side. You've got CNNs, they scan locally, they use those built-in biases as shortcuts, and they're pretty great on smaller datasets. Then you've got VITs. They see an image as a sentence, they have zero built-in assumptions about space, and they need a ton of data to learn those deep global connections that make them so powerful. And that leaves us with this really fascinating question, right? This core idea that all sorts of different data, whether it's text or images or something else, can all be broken down into a universal language of tokens. That's really the engine behind so much of the modern AI revolution. So if a picture can be read like a sentence, what other languages are out there that AI is just about to learn to speak? Thanks so much for joining me.